Okay, so talking about how we determine whether equations are functions, a different way that we see relations is algebraically. A lot of times we're given equations that we need to determine that are used to describe a relationship. And so we can see things as like y equals x cubed plus 5, or maybe 1 over x plus 5 minus y equals 3. All of these are functions. Before I tell you why they're functions, I'm going to first tell you why something would not be a function. So when we have something like y squared equals x, when we try to solve for y, we would undo the square. In order to undo a square, we take the square root. So we take the square root of both sides. And remember that when we take the square root of a number, it's not just the positive value of it, it's the positive or the negative value. And so you get this thing of like positive or negative the square root of x, which means that if you put in an input for here, like 4, your output would be the square root of 4, which is 2. So it would either be positive 2 or negative 2. So for an input of 4, you would get 2 y values back, which is not okay. And not okay, as in it just isn't a function. What indicates to us whether something should or should not be a function, generally, and especially just for this class, is whether or not there is a square on your y. So if you have anything with like a squared y term, so x squared over 5 plus y squared over 5 equals 4, which is the equation of a circle or an ellipse, this is an equation, right? It's a relation, it's just not a function. It's also true if we have something like y to the 4th equals 3. That would also not be a function. It's okay if it's y cubed. That's fine, or y cubed equals 8x. It's okay if it's an odd root, or an odd exponent. It's just not okay if it's an even exponent. Let me put a comma there so you know that those are two different things. So mostly what we're looking for here is not okay with an even exponent. So algebraically, that's how we can determine that. Okay, our last two relations. The first one is set notation. And so remember that your set notation is just like a list or a set of points. And so you can have a set that looks like this: 1, 0, 2, 1, and 3, 2. And that is totally fine. It's definitely a function. You can have a few things that can be a little confusing, like 1, 0, 2, 0, 3, 0. That is also a function. I know it can be confusing when you're seeing a repeated y value sometimes, but it's the same as we talked about the table up above. It's okay if your y value is repeated. It's okay if multiple people go to the same classroom. It's just not okay if you are told to go to 2 different classrooms. So it's okay if y values are repeated. So for instance, the points 1, 1, 1, 2, and 1, 3, where your x value is repeated. It's like, hey, I, Megan, have been told to go to room 1. I've also been told to go to room 2, and I've also been told to go to room 3. And me, Megan, would be very confused of like, which one do I go to? Which one is the one that I'm supposed to go to? So this is not okay with your repeated x values. So go ahead and take a second and tell me why this is not a function. I want you to tell me which 2 points here tell us why this is not a function. It's not a function. We've put it strictly in the column that makes it not a function, but I do want you to tell me which 2 points out of these 3 are the points that would make this not a function. So you can see here that we see some repeated x values. We also see some repeated y values, and it's the repeated x values that's an issue. 5 is going to 1, and 5 is also going to 2. And so since that is what's going on there, it is not a function. So it is not okay to see X values repeated with new Y values. Okay, last one, mapping diagrams. So remember with mapping diagrams, it's pretty much like a table, but instead of it being like a clear, like this X goes with this Y, this X goes with this Y, this X goes with this Y, it's just kind of like a list of all possible inputs, a list of all possible outputs, and these arrows that say like, okay, they go in this direction. So we can do like -2, -1, 0, 1, 4, 1, 0. So we can have like -2 goes to 4. We can have -1 goes to 0. We can have that 0 goes to 0 and 1 goes to 1. Again, it's okay if multiple arrows go to the same place. That's totally fine. If multiple arrows go to the same place, realize -1 goes to 0 and 0 goes to 0, that's fine. You've all been assigned to the room 0. That's totally fine. It's just not okay if, for instance, X, Y, 1, 2, 3, 4, 6, 4, 2. Like if 1 goes to 6 and then 1 also goes to 2, and then maybe 2 goes to 2 and 3 goes to 4 and 4 goes to 2. The thing here that's not okay is that you have 2 arrows that are leaving from 1. So it's not okay. So we can like circle that as bad. It's not okay if multiple arrows leave from the same place. So these are all of the different ways that we see and can determine whether something is a function. Lots of different ways to determine whether something is a function. If all else fails, if you're frustrated, you can at least turn any representation of a relation into a set of points. And so what you can do is you can plot these points. It doesn't have to be the best graph you've ever done, right? But for an instance, something like this, you could have like 5, 1. That seems like it would be about 5, 1. 1, 2 would be maybe like right there. But then if you do like 5, 2, then you can visually see, oh, it does not pass the vertical line test. So it's not a function, right? If all else fails, just know about the vertical line test. And the vertical line test will be able to help really solidify whether or not it is a function, okay? But it's just this idea of you being sent to multiple rooms, and that's hard to tell then which room to go to.